Hi there, folks. Today we're looking at operations with fractions. It's one of those things that students dread, and I think it's because fractions are somewhat misunderstood. All right. The thing that you really should recognize about a fraction, especially when you first start dealing with them, is that a fraction bar is literally a division symbol. Okay. So seeing a fraction bar literally means divided by this thing. And when you start to think of it as a division symbol, some of these things become a lot easier. Some of these things that we thought were difficult are not so bad, okay? As long as we think about and realize that a fraction bar is just a special version of a division symbol. It means divided by, okay? For example, if I look at just these first couple, thinking about that idea of a fraction bar as division, here we have 9 times 1/3. Well, 1/3 literally means 1 divided by 3. And yeah, we can kind of ignore the 1 for a second and just say, hey, that means we're multiplying by 1, which doesn't change anything. But then it literally says there, divided by 3. So if I have 9 times 1 divided by 3, it's literally that. 9 times 1 is 9, divided by 3 is 3. And so we tend to get really worried when we see these kind of fractions, but if you understand that that is just a division symbol, 9 times 1 divided by 3, most of us can handle that, okay? Same thing with this one. It says negative 12 times 1 divided by 4 this time. That's what 1/4 means. It's 1 divided by 4. So negative 12 times 1 divided by 4. So negative 12 divided by 4, well, 12 divided by 4 is a 3. And now, because that negative sign in there is the opposite version, so a negative 3, okay? If I look at this one, same kind of thing. It's saying times 3 divided by 2. And so if you literally say that out loud a little bit slower than I just did, 8 times 3 divided by 2. 8 times 3 is 24. Divided by 2 is 12. And the thing that's super interesting about this type of example is I did 8 times 3, then divided by 2, but the thing that's special about fractions, and the reason it's a special version of the division sign, is because those two operations are happening simultaneously, means they're happening at the same time. That times 3 divided by 2 are happening at the same time, which means I could do them in any order. I could do the 8 divided by 2 first and get a 4, then multiply by that 3 and get a 12. That's how fractions work. It's just a division sign built into the problem, okay? This one, same kind of thing. Negative 24 times negative 3 divided by 8. That's what the fraction bar means. And here's why I pointed out the idea that that multiplication and division are happening at the same time. I don't want to do 24 times 3. If I don't have a calculator, that's a pretty tough question for some of us, all right? It's easier to do 24 divided by 8, which gives me a 3, and then multiply by that 3 up top and get a 9, okay? And once again, negative times a negative is a positive. Remember, it's the opposite of the negative, so this one's going to be a positive 9, okay? Now, can you multiply the negative 24 times the negative 3 and say, yeah, that's a positive 72, and then divide by the 8 and get a 9? Absolutely, okay? But if you do some of the division first, it can make these problems a little bit easier to do in your head, okay? So keep that in mind. Fraction bars are just division signs. So when we have two fractions being multiplied, again, the numerators, we just multiply the numerators and denominators separately, and then we do the division. It's essentially saying, hey, I'm going to do the multiplication, the top, all right, the numerators, and then I'm going to get the division stuff ready so I can just divide by a single number, okay? For example, if I look at this guy, I just do 2 times 9, which is 18. And then down here, I do 3 times 2, which is 6. And essentially what I'm doing is I was dividing by a 3 and dividing by a 2. That's what those symbols mean. I'm dividing by 3 and divided by 2. That's the same thing as dividing by 6, okay? And so when I divide this now, 18 divided by 6 is a 3. That's it, okay? And notice the last step says divide or reduce. We divide if we can divide, like 18 divided by 6 is a 3. But if I can't divide, if it doesn't divide nicely, I just reduce, okay? So I divide by as much as possible, all right? The other thing to note here is, once again, I don't have to do the multiplication first. I can start with division. So think about all the symbols here. I have 2 divided by 3 times 9 divided by 2. I could do the multiplication division in the order here. I could do the 9 divided by 3 first and get a 3. So now I still have the times 2 and the divided by 2, right? Is kind of what's left here. And now I could do the 2 divided by 2 first and get a 1. And now be left with a 3. So again, the idea here is this idea of cross-reducing by doing the division first and saying 9 divided by 3 is a 3. So now that divided by 3 is gone. And then doing 2 divided by 2 is a 1. Now that division is gone. And now doing the multiplication last. Okay? But it's the idea that a fraction is just multiplication and division happening at the same time. That fraction bar means divided by, and I can do the division first if it makes things easier for me, okay? If I look at this one, same kind of thing. I can multiply first. If I do multiply first, negative 6 times 7 is a negative 42. 5 times 2 is a positive 10. And now from here, this is not going to divide nicely, so I'm going to reduce. See, 42 is not divisible by 10. So I'm just going to divide them by whatever I can divide them by, which happens to be a 2. See, I can divide the 42 by a 2, and that gives me a 21. So I'm going to put negative 21. I can divide the 10 by a 2, and that gives me a 5. And this is called an improper fraction. In algebra, a lot of times we'll accept improper fractions, okay? But really determining whether you should leave it as an improper fraction or change it to a mixed number depends on the context of the problem. For this problem, the improper fraction would be fine. So let me put a box around that one. But if you wrote it as a mixed number instead, that would also be fine. It's just a matter of saying, okay, how many times does 5 go into 20? Into 21? And the answer is 4. And again, it's going to be negative. And now, if it goes in there 4 times, there's still 1 left over, because basically 4 times 5 is a 20. So I didn't quite get to that 21. There was 1 left over. And the thing I was dividing by was a 5. So I continue to divide that by 5. Okay? That would also be an acceptable answer, that mixed number. Okay? If I look at the next one, again, I can multiply straight across. Negative 3 times 3 is a negative. Oh, sorry. I missed this negative sign here. If you see a negative sign out front like that, a lot of times what I will do is I'll write that with the numerator. Okay? You got to basically choose, do I write it with the numerator or denominator? Always just stick it with the numerator. Now I can multiply straight across. Negative 3 times negative 3 is a positive 9. Remember, negative times a negative is a positive because, again, it's the opposite of that negative. And then 4 times 5 is a 20. And this one, I can't do any dividing. I can't do any reducing. That one's done. Okay? And once again, if I backtrack to the previous question, I could have done some of the division first. I could have said, hey, negative 6 divided by 2 is a negative 3. And now I could multiply across. Negative 3 times 7 is a negative 21. 5 is the only thing that I'm dividing by now. Okay? So again, you can do the division first. Most students feel more comfortable just multiplying first and then dealing with the division or reducing. Okay? Let's talk about dividing fractions. When I divide by a fraction, I've got some circles here that I'm going to break into little pie sections. Okay? But I have 3 divided by 1/2. And if you look over here, I have 3 circles. See, 1, 2, 3. 3 whole circles, okay? And I want to break those, divide them into half circles, okay? That's what the question 3 divided by 1/2 is asking. And so if I divided each of these into a half circle, here we go. So now I divided my 3 circles into half circles. How many half circles do I have? We'll count them up. 1, 2, 3, 4, 5, 6. So when I took 3 whole circles and divided them into half circles, it gave me 6 half circles. The answer here is 6. That's what dividing by a fraction is. It's taking the whole and breaking it into how many of those little fractions do I have. Same thing here. I've got negative 2 divided by 1/3. Again, here I have 2 whole circles. Count them up. 1, 2. But I want to break those into 1/3. So I have to break each of these circles into thirds. So there we go. Now they're broken into thirds. How many thirds do I have? Let's count them up. 1, 2, 3, 4, 5, 6. The answer here is 2 divided by 1/3 gave me 6 pieces. But this one, it was negative divided by a positive, so that's going to be a -6 for our purposes. Okay? And so hopefully you're looking at this going, well, I normally when you divide you get a smaller number, but here we got a bigger number. Hopefully you see that it's multiplication that's happening here. Like here, this is 3 times 2. This one is -2 times 3. And so the concept that comes forward, and this is where we go with it with algebra, is that division is dividing by fractions same as multiplying by the reciprocal. In other words, this guy is the same thing as saying 3 times 2 over 1 if I switch that, which is just 3 times 2. Okay? This guy is the same thing as saying -2 times 3 over 1, which is the same thing as -2 times 3. Okay? So the idea of multiplying by the reciprocal just means, hey, we're going to do multiplication, and we just flip that second fraction. Okay? And so for something like this, dividing by a fraction, same as multiplying by the reciprocal, we essentially do this. We say, okay, this is 2 over 3. Instead of dividing by 9 over 2, I'm going to multiply by 2 over 9. And now once again, multiplication, we just learned that one. 2 times 2 is a 4. 3 times 9 is a 27. And now I would do the division or the reducing or whatever I can do, which I can't do anything here. That's it. Okay? This one, -6 over 5, divided by 7 over 2, is the same as multiplying by 2 over 7. Okay? It's the same as multiplying by the reciprocal. So if I flip that second fraction, now I can do multiplication. And once again, -6 times 2 is a -12. 5 times 7 is a 35. Now I would do the division, which there's nothing for me to do. Okay? And then this last one, this is the one that really gets students because we see that giant fraction. I've got a fraction and then another fraction and a fraction bar between. There's too many fraction bars. Remember, a fraction bar is a division sign. And see, the thing that makes this one look extra scary is there's that big fraction bar in the middle. So I'm just going to take that big fraction bar in the middle and say, you know what? I'm not going to write that big fraction bar as a fraction bar. I'm going to write it as a division symbol. And now it's not nearly as scary. Now I can change this to multiplying by the reciprocal. So I change this to multiplication. I flip this guy to a 5 over 3. And notice I just leave the negative sign where it is. So now I can multiply the numerators. -3 times -5 is a positive 15. 4 times 3 is a positive 12. And now once again, I can reduce this. Those are each divisible by 3. Divided by 3, divided by 3. There's my answer as an improper fraction. As a mixed number, that would be 1 and 1/4. That would also be acceptable. Okay? And then lastly, for this particular example, I could have done the division first. Once I got to multiplication here, once I got to this step, you see I could have done the -3 divided by 3 and gotten a -1. And now multiplied -1 times -5 is a positive 5. 4 is the only thing I'm divided by. There it is, 5 over 4. Okay? So keep that in mind. Once you're to that multiplication step, you can do some of the division first if you would like. Okay? Let's talk about adding and subtracting fractions. Adding and subtracting fractions is the tough one. Multiplication division should be the easy versions of this thing. Okay? And so if I looked at something like this, 1/2 plus 1/4. So here's the concept. If I cut this guy in half, okay, there's half. And this guy, if I cut into fourths, imagine taking those two chunks and trying to form a circle out of those chunks. Okay? So if I were to come up with a new circle here, I'm just going to freehand this circle. Say, okay, let's put all those chunks together. So I had this chunk, that was the 1/2. Let me put that right here. And then I had this other chunk right here, that was this guy. The question is, what fraction do I even have now? Okay? And maybe you can look at that and say, well, I think it's 3/4. I think 3/4 of it is filled. Okay? The trick to this is to basically look at these pieces in similar context. If I were to just add another line to this first guy right here, you see now that instead of having halves, I have 1/4, right? Each section is a fourth, so right here I have 2/4 when I look at these two pieces. And here I have 1/4 when I look at this one piece. And in the final answer, if I continue that line straight across, if I have this broken down into 4 pieces, what I have is I have 3/4 of the pieces covered. And so the idea here is the idea of common denominators. It's the idea of looking at these things if they were broken down into the same number of pieces. Instead of looking at the 1/2 as a 1/2, look at it as 2/4. Instead of then looking at the answer as these two strange chunks, I can easily see now that it's 3 out of the 4 pieces, okay? So conceptually, having the pieces broken down into the same sizes makes them easy to put together to form circles, okay? If I look at this one, same kind of thing. This one's a little bit trickier. Okay, so I have 2/3 and I have 1/2. So let me break this guy into thirds. Okay, and I want 2 of those thirds filled in. Let me use my crayon now. Crayons are great for this. Okay, so I have those 2/3 filled. That's not very good coloring, Mr. Jansen. You're doing a terrible job. I'm not good at it. The 1/2, if I break this thing in half, ready? And so let me fill in half of it because I only have 1/2. But see, the tricky part is if I were to break these pieces out, you see if I try fitting that 1/2 piece like somewhere into that first circle, it's not going to match up right, okay? The pieces aren't going to match up because they're totally different shapes and they don't fit together properly, okay? So what I need to do is I need to break these into more pieces. I need to take something like this first guy and say, you know what? Let me extend this guy and cut that piece in half, and this piece, and this piece, okay? If I cut all those in half, now, instead of having thirds and having 2 out of the 3 pieces filled, I now have 6 pieces, and I have 4 out of the 6 pieces filled. So now the concept here is I'm looking at 4 out of 6 instead of 2 out of 3. So you have these 4 pieces. And it's the same thing over here. I want to break this into the same number of pieces. That was terrible, and I'm ashamed of myself. I can do better than that. I believe in me. There we go. Now I look like a math teacher. If I break that down the same way, see, that's 3 out of the 6 pieces now. And so if I start taking all these pieces and chunking them together, I have 4 pieces in the first one. I have 3 pieces in the second one. So I have 7 pieces out of the 6 total. So it's 7 out of 6 if I were to start to piece those together. And if I actually started to piece these chunks together, like if I took these 2 pieces right here and filled them in as these 2 pieces, I'd have one whole piece and then one of those 6 pieces left over. And that's the answer as an improper fraction was 7/6. But as a mixed number, it would be 1 1/6. Okay? One whole with one left over. Okay, and either one of those would be an acceptable answer. But the idea here is in the previous one, I looked at those fractions in terms of fourths, in terms of having a denominator of 4. And in this one, I looked at the denominators in terms of having a denominator of 6. Okay, when they're broken down into the same number of pieces, I can add those pieces together. And that's the idea here between adding and subtracting fractions. You need common denominators, okay? You need to have the same number of pieces for each thing. And to find a common denominator, we look for common multiples. A common multiple is if I just look at the list of multiples of a number, like the multiples of 2 would be 2, 4, 6, 8, 10, all right? The multiples of 3 would be 3, 6, 9, 12, 15. If I compare those lists, I just look for a number that they have in common. That's what a common multiple means. So in this first example, see I've got 3, which is 3, 6, 9, 12. Those are multiples of 3. Multiples of 2 would be 2, 4, 6, 8, 10, 12. And see, I just have to pick one that they have in common. Like I could choose the 12. And I could do each of these out of 12 and then be able to add the pieces together. But what we typically look for is the least common multiple, call it the LCM. We're looking for the smallest thing they have in common, which in this case is the 6. And the only reason we do that is because it keeps the number smaller. Would it be wrong and would it if you use the 12? No, you would just have to do a little bit more work, okay? So I want this out of 6 pieces, and the mathematical way to do that is say, okay, to turn the 3 into a 6, I have to multiply by 2. And I have to do the same thing to the numerator, okay? It's kind of undoing the process of reducing a fraction. So that's 4 over 6, okay? And that's the same thing. 2 out of 3 is the same thing as having 4 out of the 6 pieces. We just did that a little while ago, okay? And then this one, to turn the 2 into a 6, I have to multiply by 3. And I do the same thing to numerator and the denominator. So now what I have here is 27 out of 6. Now I have the same denominators. They're out of the same pieces. So if I had 4 out of the 6 pieces and I added 27 more pieces, I have a total of 31 pieces. And yeah, those pieces are broken down into sixths, okay? So I add the numerator to the denominator stays the same. And once again, I could leave it like this, or I can write it as an improper fraction. 6 goes into 31 5 times with 1 left over. Okay, there it is as a mixed number, okay? If I look at the next one, again, we want to think about the common multiple. What can each of these multiply to become? And the answer for 5 and 2, I think the least common multiple is a 10. And so I'm going to multiply this first guy by 2. I have to do the same thing to numerator and denominator. I'm going to multiply the second guy by 5, numerator and denominator, which gives me a negative 12 over 10. This one gives me a 35 over 10. And see, now I have them out of 10, so now I can add those. Negative 12 plus 35. Again, think about what would cancel, what would be left. That's going to give me a positive 23, and it stays out of the 10. Or we can write it as an improper, that's an improper fraction. We can write it as a mixed number. That would be 2 with 3 left over. Okay? If I look at the next one, the first thing I'm going to do with this one, because I see minus that negative, I'm going to change it to the opposite. Instead of subtracting, I'm going to add. Instead of a negative, I'm going to do a positive. Okay? Remember, subtraction, changing it to adding the opposite is always a good idea. Makes things a lot easier for us. Okay? Now the common denominator between 4 and 5 is a 20. So this guy I got to multiply by 5. Numerator and denominator. This one I have to multiply by 4. Numerator and denominator. And so I get a negative 15 over 20 plus a 12 over 20. And now that the pieces are the same, I can add them up. Negative 15 plus 12 is a negative 3. And it stays out of the 20. And this one, there's nothing that I can do to reduce it or change it. Okay? Last thing we're going to look at here is operations with mixed numbers. The idea here is just to change those mixed numbers to improper fractions first, okay? We've been changing the improper fraction to mixed numbers. Now we want to go backwards, okay? And so to change an improper fraction to a mixed number, we divide it and then counted up the remainder. So now we're going to kind of do the reverse of that. We're going to multiply and then add on the remainder, okay? So for example, if I look at something like this guy, 2 and 1/4, I'm going to do 2 times 4 to see how many pieces I got from the 2 wholes. So 2 times 4 is an 8. And then I'm going to add on that remainder of 1, which is a 9. So that means I have 9 out of 4 pieces. Okay? The tricky part about this is you have to ignore negative signs. Okay? The negative sign gets tacked on after we do this conversion. So for this one, I say, okay, 3 times 3 is a 9, so there's 9 pieces from the whole, from those 3, and then tack on that remainder of 1, so that's 10 pieces out of the 3, and now tack that negative sign back on, okay? And now it's multiplication. I can do my division first, or I can multiply straight across. I think most of you probably feel more comfortable doing 9 times negative 10 is a negative 90, and then 4 times 3 is a 12. And now reduce the fraction That's a negative 40. Oh, sorry, I can go bigger. I can divide each of those by 6. So that's a negative 15 over 2. Okay? And again, you can leave it as an improper fraction or write it as a mixed number. That's negative 7 and 1/2. Okay? Either one of those would be acceptable in my book. Okay? If I look at the next one, again, it's division, but don't worry about division yet. Change everything to improper fractions first. So here, 1 times 5 is a 5. So there's 5 pieces from the whole, and then plus that 1 remainder, that's 6. So it's 6 out of 5. Now, tack that negative sign back on, okay? And now here, division, I can change to multiplying by the reciprocal. So I flip this second fraction. And now I multiply. Negative 6 times negative 10 is a positive 60. 5 times 7 is a 35. And now once again, I can reduce this. 3 is divisible by 5. 60 divided by 5 is a 12. 35 divided by 5 is a 7. Leave it as improper fraction, or write it as a mixed number. That's 1 and 5/7. Either one of those would be an acceptable answer. And then the last one here, once again, I'm going to change this to an improper fraction. 1 times 5 is a 5, plus 1 is a 6. So 6 out of 5, then don't forget to tack on that negative sign. I also see minus and negative, so I'm going to change that to adding the opposite. So adding a positive. And now because this is addition, I have to get common denominators, okay? Common denominator is 10, so I'm just going to multiply this guy by 2 over 2. That gives me a negative 12 over 10. The second fraction already has the denominator that I need. They're already the same. So now I can add them up. That's a negative 5 out of 10, which of course is the same as a negative 1/2. Okay?